All morning, the last few months, I've been trying to simplify and make it to the next step. My goal is to be able to predict the remaining particles left to be found from CERN. And I'm so close, like it's like on the tip of my tongue, sort of feeling in my brain on how this works. It's what I'm trying to design is sort of like a calculator, and analyzing how particles balance and then their subquantum build up to quantum states, and where interference starts happening, or maybe even the derivative of interference is subquantum. But to start off, I think the best is, let's see, the hydrogen atom. And on my periodic table, hydrogen has an atomic weight of 1.008. So, if you try to add that into that, what is the mass, the volume, and the size of a constant of a hydrogen? What if we had a perfect vacuum and hydrogen in a hydrogen atom? What would be its null particle mass? What would be its subdivisional mass, so that we can figure out density divided by volume, volume divided by density, and then your subdivisional mass and standard mass to create a null particle structure. And then we can build up from probability of the balance of, say, two hydrogen atoms structuralized around a gravitational model and my wave system here to calculate forces and energy and interference, essentially. And it's really I keep getting confused every time I make it to that point. I get a little confused, and so it's because I know it'll work, but how does it work? Why does it work? And where to take it next, and to unify it with like a cosmology, Hawking radiation, and all that other stuff too. So it's just like, take it to the next step. That's what I did here. When I wrote this out, one thing at a time, and it's just overloading me, because the next step requires a whole lot of things. So okay, so the fundamental value, my whole philosophy is trying to find the last number of an infinite number, and then, because any number in between there can be an infinite set, and so if we can rationalize that, we have a fundamental value. And that was what I was considering to be a fundamental value. 1.0, infinite set of zeros repeating, ending in 1. And that's why I wrote that number structure, to explain how many numbers and what you can have in the middle. And so we need to find, with hydrogen, let's see, I think there's one proton, but they also have one neutron too. There's like different, the hell they call those? The fuck do they call it? Well, they got more neutrons than protons. Anyway, so that's hydrogen. trying to figure out how we divide into that. Oh, right. Where are the quarks? Where's the standard model? And what makes up these standard models to get the balances that they do and the charges that they do? Because I think there's a lot more than just these, especially with quarks, ions, photons. And that kind of annoys me. Anyway, yeah, I'm not trained in all this, so I'm going off. So the Higgs boson is what they're saying is the fundamental, is like a singularity. But I don't see it like that. I see it a little more complicated, like, if that's what that's saying. So already we know, goddamn, like this, no particle mass. So if we have an atomic mass of 1.008, or I guess that's atomic weight, it's molar mass, right? Molecular mass. Then what is the volume and what is the density? So mass 1 is all of this. Mass 2 is all that can fit within this. All the potential particles that can make up this mass. And that sets the limit. I just don't know how to find that limit with atomic weight only. So a hydrogen nucleus, one proton, is made up of, what is it, like 2 up quarks, I think. And I just think that's overly simplified. I know it goes a little bit more deeply than that. I mean, what causes 2 up quarks to bond and be formed around with all these quanta particulates? And I knew all this stuff. I don't know why I'm forgetting it. So what makes up the Higgs boson? That's what I guess I'm trying to do with subquantum physics. In that, so we have our black hole. I like to draw them like this, because to me, I suspect that that it's not just hairs, it's like weaves and just all this complicated network of probable particle structures that are trying to quantify into a singularity at the core. Now, what is pulling into the core? Why is it pulling into the core? Personally, I believe they are electrons. I think there's something attached to an electron, similar to a positron, that electrons don't actually have simply a negative charge. I believe they are bipolar, and that polarity flips in its field. Like I said, there's so much to just go through. Okay, so here, let's say this is a black hole. The outside of a black hole, as Hawking said, has a lot of little hairs. And through Hawking radiation, one subquantum particle is emitted at a time, and this sort of evaporates, right? So the black hole's evaporating outwardly. This is why I believe there are hollow particles. There is a positron that is hollow, and it has a perfect vacuum within itself. Now this thing is so fucking small. It's as small as I can imagine. Smaller than quanta. And maybe that's what Einstein meant when he referenced quanta, I don't know. But how does this turn into this? Well, that's where my theory is going. That's what I've been working on and trying to figure out. And I don't have much time left, so I'm going to explain it as best as I can to get to where I was trying to go. Now, okay, so if you were to take a series of these, they would form a string. Or they would wrap in a circle and you would have multi-vector dimensions, which I suspect is where all those dimensions come from. So, you got your subquanta bonding, they overlap, they string together, sort of like that, right? And how they overlap, then they can go in half, and there's a probable variance between two of these subquantum positrons. I don't know what you call them. Call them that sounds fine to me. And they can almost sort of pass through one another. They can bond, they get stuck. It all depends on how. So I'm looking at the center of a black hole as an electron. To me, it is an electron. I mean, that's the only rationality I've ever been able to find. So we have an electron. Why else do they pull towards the center? But what repulses them? Why are electrons kept in a quantum atmosphere? So as Hawking radiation happens, I should go open my door. I need to let fresh air in. My eyes are burning again. And it's like it's all in my head. It's just translating it to English is really difficult for me. Organizing it all is really difficult. So, but I know what I'm trying to say. I gotta go open my door. I'll be right back. So much to think about. So, how does this form the various quarks for the standard model? Gluons, protons, whatever else is on here. Let's see. I don't know what a charm is. A strange muon, neutrinos. So then we got neutrinos, which I suspect could be the positron shell that I'm talking about. It's just that would lead into an even smaller form of quantum, subquantum physics. Where do we set the limits? And you gotta drive yourself crazy going smaller and smaller and smaller forever and ever and ever. I don't know. But, okay. So we have Hawking radiation. This is a fundamental particle that forms all matter. Now, why and how does that turn into that? Maybe that's the Higgs boson. Is that what it is? I don't know. I don't know. I like to go at this with my own imagination, so like I've said countless times in my many roads to lead to the same conclusions theory, it gives everybody the opportunity to pursue this stuff the way the old masters used to, which is so much more satisfying than sitting in a class being told. It is something I've found worth living for all these years. It's honestly the only thing that kept me alive, is using my imagination. So the variance, the size of these particle shells, is there a variance? Can there be a small one and a larger one? And if there can be, and Hawking radiation isn't simply one constant of evaporative energy, which would correlate into entropy, right? And quantum variance. Fucking dogs, dude. What is with people and letting their dogs bark wildly and openly? I can't even open my door. This whole year, getting off track again, has been derailed by people around here because I'm moving and there's a fucking hummingbird every single day buzzing my windows, and I'm talking for months, non-stop. Then they decide to get a dog, and this dog just starts barking, and then the neighbor's dog starts fucking barking. If I try to sit outside and play guitar, they decide to go out and cut wood with a fucking table saw. People are just, ugh. Anyway, back to my point here. I tend to think better when I'm angry, too. So if one can be larger, how many vectors can we create from building up, say, like that? And it fundamentalizes that same bond, right? One null particle. A null particle is a shell of matter that creates and stores within it a perfect vacuum. And within that perfect vacuum lays the potential of a quanta, an electron that has a perfect density to interfere with and be trapped with. And so this creates, and I'm going to end up drawing that. That's supposed to be, we're just going to say, it's a hydrogen, right? H1. Hydrogen 1. I forget how you write those. H1. Do they put a 1 over it? I think it's like that, right? Something like that. It's been a long time since I've been in school. So how we trap these perfectly dense, which then it leads you into thinking, like, what's the shell made out of? Well, the shell is perfect density, but it's very thin, right? So it's got to be really thin, and that mass equates to the mass of a null particle at the center of a black hole. So it's just so hard to explain. I need to quit complaining. Okay, so with these is a field that emits, and this is what I believe is space. This is exactly what I think space is. Why it's black, why we have a speed limit, why you can't just go faster and faster and faster, not simply because of colored glass condensate and what results in time being incapable of continuing in a standard model, but also all the paradoxes in physics. So every once in a while too, so, oh my god, yeah, we completely forgot about that. Okay, let's see, we're gonna draw this in half here. Before Hawking radiation can happen, this has to build up. This is getting to a certain it's sort of like a critical mass state, right? What is the critical mass of a black hole? Of an infinitely dense particles mass state. What is? I swear, every time I make these videos, I start hiccuping, or It's ridiculous. Okay. And maybe Penrose does all this too. That'd be really cool. If anybody wants to mention the theories, let me know. I give credit where credit is due. I just want everybody to know that I have not studied this. So I took my chance. This is my chance to prove myself as a natural genius. I wanted a honorary PhD in particle physics. I thought it'd be really cool to have. And I mean, when the guy who invented the microwave, that guy had an honorary PhD. I heard that. I was like, wow. Now that's cool. That sets you apart, you know? It's just boring to sit in a fucking class. And I love listening to people talk about physics, but nothing's more satisfying than stretching your imagination to the smallest point. When you're as small as you can imagine, to as large as you can imagine. And then you build it up in between, back and forth, over and over and over again until it gets bigger and bigger and bigger. And that's one of the thought experiments I figured out and invented so that I could work out my imagination just like a muscle, essentially. And so, how these electrons at the event horizon, right there. So you have your basically this fundamental particle that is split off, positron mass reflects, and something accumulates at the core, while these shells create a weave, like hairs, like a network, like a net, like Hawking said. And it's so cool to think about. So the event horizon, there's like a filtering that happens then. This null particle, whether that's the null particle or that's the null particle, maybe there's a positive null particle and there's a negative null particle, which is I think why I wrote 1 and 2s for there. So we have null particle 2, null particle 1, 2n squared pi equals x times n equals 1n to derive null particles. So if we know the radius, if we know the volume, then we can calculate all this stuff. And, right, so at the center here, oops. See, the only reason why I think this is because why are electrons not just exploding outwardly? It doesn't make why there's a quantum atmosphere of electrons around every nucleus of an atom. And why can't we just take an alpha particle from nuclear radiation, put a plasmic field around it, and make helium? I don't understand why. It's got to be quantum interference and probability. So there's something happening that destabilizes these bonds that want to equalize everything and allows for an electron to not simply just be a null perfectly dense particle. Electron bonds with the positron, as we know, to form photons, and that goes back to this drawing whenever I drew it. There we go. Me trying to understand photon decay, or just atomic decay in general. That I assumed a positron comes from a proton, and how waves form and that stuff. Okay, so a positron is emitted, the electron is sort of attracted, right? They interfere with one another. But should really bookmark these. And once in a while, as this grows, this has to evaporate too, because the filter layer has already been formulated. And so, once in a while, then you get a null particle that is emitted as well. So you have these two fundamental states. It's not just a singularity. I believe these would be considered the singularity. Right? What's at the center of a black hole? Many hypothesize that it is a singularity. And if it's infinitely dense, well then, I agree with that. So, I sound like a crackhead right now. So, as these emit, they have different interference networks, all sorts of things to just fundamentally fabricate space, essentially. And these can bond with these, so you get all these little variables happening. Say one catches there. Say one is in the center. That then has variance. So I know I'm going to keep using the same drawing. I really should work that out, but then you can say, like, there's all this variance in here for this, for distance. Then you got bonding. So it's like a micro black hole, I guess. Maybe that could be what they're studying, eh? And then, as I mentioned, they can switch, they can exchange. There can be orbitals. Which can go around the outside, or it can go around the inside. It can fluctuate. I'm looking through my phone and drawing again. It can orbit around the shell too, in and out, sort of. And the way that can pattern has variables. So it's don't just think of it like a ring, and it's just going around the ring. It's a shell, it's a sphere that it's going around like a ring, in and out. And all sorts of funny shit can happen. So this is how I fundamentalize, and it's like, maybe this isn't all right, but what's the limits that we can find from this? And if we build this up enough and find all the variables, then we can understand how matter, my hand is up shaking, structuralizes, and how quarks form, and how the very just well, I guess quantum, so quantum is subatomic, right? And so quantum builds up into quantum to formulate these structures that allow quarks to be formed as they are. So, and that's, Jesus, my hand. Oh, I'm so shaky today. Part of the Pringles I ate. I ate a bunch of Pringles. Okay. So this is where it gets interesting. At the center is E. It is surrounded, and these bonds can happen. Every one of these can form to create our quarks. So then you got, a particle attached to another positron. Doesn't mean that there is another one at the center there bonding to that. However, you have all these other variables that can incorporate into that through just a random encounter. And it's super rare. It's about as rare as trying to create nihonium. Probably even crazier, honestly. And now, how these can all build up is sort of like, let's see, our Feynman diagrams and how they can structuralize. And that's similar to how I think of it. This is when I was trying to use it to understand concepts of cyclic energy, but Feynman diagrams are a perfect example too of how you can use these to structuralize all of matter. So maybe his method is better than mine. But I'm trying to design a sort of calculator. And we can input our probabilities and then structuralize around it, and then say every quark that's been discovered, if you were to cut those in half and piece those together with other quarks and other gluons and neutrinos, then how many of these all put together can create larger subatomic particle states? And the number is astronomical if you start off from here. And how these can all form, to figure that out. So weave happens E at the center. We have our expansion. We get one particle in the shell. And think of it like Jesus Christ, my hand. So you have your shell, which is basically like a photon interfering, which that's what I think a photon is, you know? It's essentially that happening. It's not just a positive and a negative equating till particle annihilation. It's a hollow shell with an electron at the center, which is why I believe black holes are made up like this, and why photons and photon annihilation, all this stuff correlates. So this turns into a shell, while a little bit more mass is going outwardly at the event horizon. And then your electron, which is technically your singularity, right? And now I probably should just look up Hawking's theories and explanations of this, but that's how I interpret it. So after Hawking radiation comes all these little variables to restructuralize matter. Where do particles come from? Why does interference even happen? Well, like I said, then you have these perfect little vacuum shells that, as they expand, as the radius increases, as we know, volume increases 20% for every 10% of radius increase. So one might take a higher velocity of a pass. So that's going to either pass through, or it's going to bond. It's going to want to stay in the center, or it's going to interfere. And then that's going to interfere, and it's all just going to start interfering and being silly and crazy until we build these up into the standard model of quarks. And I guess ultimately the Higgs boson, I suppose I could read about it all and figure out where all this stuff goes and then finish my theory, but this is just me trying to get to the next step right now, just to get all this stuff that I've been thinking about the last week out and figure out where these bonds happen, why they happen, and then how this starts to formulate particles. And how this then, so you have that, and then another singularity bonds there, or it can bond anywhere else. It can bond there too. It can bond anywhere along this path. It can bond to the same ring or not. And then So there are these that sort of wander around the universe looking for the right balance to bond again, and how that can bond to that over there, and then it just builds up and builds up and builds up slowly over time, bonding singularities with subquantum positron shells. And that explains why electrons are pulled towards the center of the nucleus. But why are they repulsed? Through nuclear evaporation, or Hawking radiation, I guess, at the nuclear level, and positron decay, photon decay, proton decay, is emitting these same things that bond and pull. Like in my other drawing, how they were emitted from the nucleus of an atom, they bond and pull just a little bit of a charge, and that destabilizes it, accelerates the electron. It's sort of like a satellite, right? And how a satellite stays in orbit. Concepts scale. They scale no matter what. That's why they exist. And so many concepts that we have and use in physics can all be derived and fundamentalized through quantum and subquantum physics. Except, where does quantum probability come from? Well, that's what I'm trying to explain here. There's just so much to say. This is all I've been thinking about for the last 6 years. 7, 8 years since this philosophy, and then I figured out my cyclic mass generator, and I knew I needed to pursue philosophy and physics and other things. And so, getting into that, and I can talk about this for hours and hours and hours. Jesus. So when mass 1, standard mass divided, or times derivative mass? What? I think that's supposed to be divided by. But anyway, however we can equate to that number to fundamentalize and rationalize pi to find our two states of mass 1 and mass 2, can then calculate our null particle and variables to every bit of hydrogen atoms that are out there. What do they call those? What's wrong with my brain? Can't think of a word. Brain fart. But anyway, how neutrons and why neutrons even exist at a nucleus of an atom, I mean, it makes no sense, right? And I think I'm going to end it pretty much here. Still working out how we correlate a fundamental value, and then we can figure out a system to build up to creating limits, and then calculate undiscovered particles and how many there can possibly be. So right now, there's 53 or 54 someone has discovered. And it's like, how many of those, if you chopped them in half, and chopped them up, and just kept chopping them up, and combining them, and you just put them in a vat and just mixed everything around, how many of them would turn into other particles that we haven't discovered? How many variables are there really to how many particles can possibly exist? And so it correlates around that. I mean, how does the core of a black hole become infinitely dense? Why does it evaporate? Why are there hairs? And it's probably a net, it's like a weave, right? And of these perfectly vacuumous structures that can store and allow perfect density to form without repulsion. And as you know, I mean, and she put a firecracker in a swimming pool. That's a bad example. Dynamite, I don't know, gas displaces, but the water viscosity and pressure, because of that pressure outwardly, causes it to shrink back in. Well, that's kind of what happens with space too, right? Space doesn't push outwardly. How could space, a vacuum, as we know, if we vacuum seal a bag, all matter is pulled into it. So logically, to house these infinitely dense particles, these subquantum, or these quanta atomic particulates, are, I think, the fundamental particle state that really ends and fabricates reality for us. It is why we have particles that form, why we haven't just all just decayed into one giant black hole versus one infinitely dense singularity that makes up all matter in the universe. And it's just logical to me, I guess. It's the only thing that sort of makes sense based on the velocity interference. And so, obviously, Hawking radiation cannot have a consistent velocity. There's got to be variance in the weave, in the shell, in the hairs. And that would lead to, say, that being emitted rather than two interfering and making contact later. And then that hits something and that accelerates it, and that inertia, that rotation, harmonically stabilizes and creates a mass stabilizer that then allows for particles to bond, similar to like the Pi's effect, I guess. Yes. But I don't like to call it that. I think he could have been more creative with naming his theory. Anyway, so if these two encounter one another, are they going to bond? Are they going to carry the same path? Are they, if they do, say they don't really bond, they have potential to not create force. And two of these just happen to come out together, just right near each other, and they're both just together. And then they encounter one of these shells. There's one shell, or say there's a bonded shell, and this has rotation. And they encounter. And there's so many variables. It's fucking unbelievable how many there are. And I believe all this is how we get this just fragile balance between atoms. Why there's even a quantum atmosphere at all of electrons. Why they're pulled towards the nucleus. Why the nucleus of an atom even stays together, as we know positive and positive want to push outwardly, right? Well, then if I take two magnets, I can always glue them together. And so you got gluons and muons, and I don't know what a tau is. Top, down, bottom, strange, charms. I don't know. I've never heard of those. You get bosons, gluons, photons. And, anyway. So much. So then, yeah, I mean, that's... turns into all of that, if that's what that's trying to represent. I bet it is. Except then there's a sub-quantum state. So that's your quantum. And then you have sub-quantum that builds up into that. And I know I'm probably sounding really silly by saying that. Maybe the Higgs boson is the singularity. Either way, there's got to be a way to do all this to calculate the probability of quantum interference and how two particles like that interacting create okay, so that's another thing. Quantum improbability. So say we have two particles like this. One has velocity this way, the other this way, and they don't want to bond. Maybe one rotates just subtly, the other one rotates as they interfere. Stay focused, phone. What's wrong with you? Or they repulse. They just happen to meet perfectly. And the shell almost wants to compress. And then they spread outwardly, back the way they came. And that goes into some quantum structures of these. So I don't know what scale I'm really fucking on, but I believe that just simply these shells that make up the hairs aren't even themselves perfectly dense, perfectly thick. There's got to be, say, one, if you were to cross section it, you have like more thickness here. Or one that is just ever so slightly bonded but broken too. And so there's like all these variable possibilities for this as well that create different weaves, and say then that those are made up of their own strings of these infinitely dense quanta. And I think that's everything.